Okay, so I'm kind of picking where we left off. I'm not going to do every single problem, but I will definitely do at least one type of each of the problems, or one of each type of problem. That way you can see what's going on. So the next one up was 24e, and it was log of 1 million. There is nothing there, so I assume that's the same as equals x, and I have to solve for x. The only way I can do this is if I change this to an exponential, or if I do my change of base formula. So if I want to do my change of base, then there is no base, so I assume it's a 10, and I would do log of 1 million divided by log of 10. And when I put that into my calculator, I get 6, because 10 to the 6th equals 1 million. F then is 10 to the 3 log of 2. As I mentioned in the previous problem, or a couple problems ago, if I want to try and cancel, I have to make sure that any logarithm in my exponent is written in as condensed form as possible. So this 3 has to become an exponent on my 2. So this is the same as 10 to the log of 2 cubed, which is going to be 8. So it's 10 to the log of 8. Then I notice that log of 8 doesn't have a base listed, so I assume it's base 10. If it's base 10, and I'm taking 10 to the log of a base 10 power, the log 10 and the 10 cancel each other out, leaving just the 8 as my answer. So anytime we have a base raised to the log of the same base, the base and the log cancel, leaving just whatever I was taking the logarithm of. G is another change of base problem, so I don't think we need to do that one again. This allows us to move into 25a. And we're not doing 25b, so we're just going to do 25a. And it says I have 2 natural log of x plus 3 minus natural log of x plus 1 equals 3 natural log of 2. In order to solve this, I'm clearly going to have to at least condense my left-hand side. So when I condense it, I need to move any number that's in front of my natural log up into the exponent. And I will use one of my logarithmic laws to condense. So the 2 becomes an exponent, and I get the natural log of x plus 3 squared minus the natural log of x plus 1. And then equals the natural log of 2 cubed, because I moved that 3 up into the exponent as well. I know subtraction actually means division. So then this is the same as natural log of x plus 3 squared over x plus 1 equals natural log of 2 cubed. The really cool thing now is I have a natural on the left and a natural log on the right, just one on each, so they can cancel each other out. And then all I'm left with is the x plus 3 squared over x minus, or x plus 1 equals 2 cubed, which is 8. And then from here, I'm going to cross multiply, I'm going to simplify, and I'm going to solve for x. So I go ahead and I multiply the x plus 1 over to my right-hand side. And then I FOIL out my numerator. When I do, I get x plus 3 times x plus 3, which is x squared plus 6x plus 9 equals 8x plus 8. I go ahead and I move everything over to the left. So I get x squared minus 2x plus 1 equals 0. I could use the quadratic formula here, but I don't really want to because I see that it factors beautifully. I'm looking for 2 numbers that multiply together to get +1 and add to get a -2. To me, that's -1 and -1. So this factors into x minus 1 times x minus 1. I'm looking to solve this, so I set each of these equal to 0. And when I do, I get the answer that is x plus 1. Since it's listed twice, I only have to list it once as my answer. It doesn't have to be included twice in there. Okie dokie. So now we're going to go ahead and move into 25C. So in 25C, I have 3 to the x squared equals 7. There is no logarithmic shortcut for this one except for to change this into an exponential problem. But even then, like it's already an exponential and I can't do an exponent of an exponent. So I'm actually going to go the opposite way and change this into a logarithmic function by taking the log of both sides to hopefully bring that x squared out front. So I take the log of both sides here. When I do, I can bring this exponent out front. It becomes x squared times log of 3 equals log of 7. I can go ahead and divide the log of 3 over to the right-hand side, and I get x squared equals log of 7 over log of 3. I have x squared equals that, so I need to include, or I need to find a way to solve for just x. The only way to do that is to square root both sides. So when I square root it, I get x equals plus or minus the square root of log 7 over log 3, and I can put that into my calculator. When I do, I get the decimal 1.3309. Next thing I have to check is just to make sure if I plug that back in, that I'm not going to get a negative inside of my logarithm, and I don't. So both of those are the correct answer. Moving into 26, I'm not going to do A because all you have to do is plug in some values for t, and then you put 64 in for n naught, and you'll just graph it by plugging in, I don't know, 4 or 5 x values. So then in B, it wants to find the half-life of my iodine. So the original equation it gave me was n equals n naught of 0.5 to the t divided by 8 power. If I'm trying to find the half-life, I'm assuming that my amount is going to be 1/2 of whatever amount I originally started with. So I say that n equals 1/2 n naught, or that's the same as n naught over 2. I go ahead and I plug that in for the n, and I get n naught. I'm just gonna do 1/2. So 1/2 n naught equals n naught times 0.5 to the t divided by 8 power. My goal is to get t by itself, so I need to divide the n naught over. When I do, I get n naught divided by n naught, which cancels out. And then I'm left with 1/2 equals 0.5 to the t divided by 8 power. So as I'm looking at this, there's not a whole lot I can do because I still have a variable in the exponent. So I need to find a way to bring that down. And to do that, I'm going to take the log of both sides and then use my logarithmic laws. So when I do that, I get log of 1/2 equals, when I take the log of the 0.5 t to the t divided by 8 power, that t divided by 8 comes out front. And then I'm just taking the log of that 0.5 base. I need to go ahead and divide by that log of 0.5 from the right-hand side. When I do, I recognize that log of 1/2 and log of 0.5 are the exact same. So they're going to go ahead and cancel each other out, and I'm just going to have a 1 equals t divided by 8 because the fraction 1/2 and the decimal 0.5 are the exact same. You could also put it in your calculator, and you're going to get 1 as an answer. So then I have 1 equals t divided by 8. To get t by itself, I multiply the 8 over, and I get 8 equals t. Which means that the half-life for this specific problem is 8 days. Next, we're moving into 27A. I told you, or I think all my classes, that 27B will not have a likeness on the final exam, although it is a really good problem just for you to practice with. So we're just going to focus on 27A in this problem. So it tells me that my function equals 10 times the log of I divided by I naught. And it wants me to solve for I. First thing I need to do is divide the 10 out. So when I do, I can't remember what Greek letter this is, so I'm really sorry. Might be alpha. But this divided by 10 equals log of I divided by I naught. I recognize now that my variable, or what I'm trying to solve for, is not in the exponent. In fact, it's inside my logarithm. So to get it out of my logarithm, I can go ahead and change this entire thing into an exponential function. We know that since there was no base listed, the base on my logarithm is 10. So I'm going to have 10 to the alpha over 10 equals I divided by I naught. And then to get I by itself, I just multiply the I naught over. And I get the finished product that is I equals I naught times 10 to the alpha over 10 power, or whatever Greek letter that is. And then we are finished with 27. Moving into 28. '28 says that in 1790, Ben Franklin left $4,000 with instructions that it goes to the city of Philadelphia in 200 years. If it was worth if it was worth $2 million at that time, so if my A of 200 equaled 2 million, it's asking what the approximate annual interest rate was for this growth. So the fact that it said annual in there and not continuous means that I'm not using PERT. Instead, I'm using the A equals my principal amount times 1 plus R over N to the NT power. My principal amount was the 4,000 that Ben Franklin started with, times 1 plus R is what I'm solving for, divided by 1 because it said annually, to the 200 times 1 power. And then this is going to be equal to 2 million. I, of course, can simplify what's inside of that a little bit. So I'm going to have 2 million equals 4,000 times 1 plus R to the 200 power. Now I need to start and get R by itself. So I'm going to divide each side by the 4,000. When I do, I get 500 equals the 1 plus R to the 200 power. I need to somehow go ahead and I need to somehow bring that 200 down. In order to do that, I'm going to take the log of both sides. So I'm going to have the log of 500 equals log of 1 plus R to the 200. Okay. So I'm going to bring the 200 down front. So I get log of 500 equals 200 times log to the 1 plus R. I'm going to divide each side by 200, which is the same as multiplying by 1 over 200. Any number in front of a logarithm was originally an exponent, which means that this can be rewritten as log of 500 to the 1 over 200 power, which just means I'm taking the 200th root of 500, equals log of 1 plus R. I now have a log on both sides with the same base, so they cancel. And I'm left with 500 to the 1 over 200 equals 1 plus R. To get R by itself, I subtract 1 over. And I'm going to have 500 to the 1 over 200 minus 1 equals r. Of course, I can go ahead and put that into my calculator, and I get r is equal to 0.03156. I like to represent my interest rate as a percent. So I'm going to move this decimal 2 places to the right. And I say this is approximately 3.2%. Or actually, I'd say 3.16. That's a better approximation. Next, we're going to go ahead and look at 29. So 29 is a lovely composition function. So it says that given that f of x is equal to x squared and that g of x is equal to 2x minus 3, I would like to find f of g inverse of 5. Since I'm taking g inverse and plugging it into my f function, I first have to actually find out what my g inverse is, right? So in order to do that, I'm going to switch the x and the y in my g function, and I'm going to solve for a y. So I'm going to add the 3 over, and then I'll divide by 2, and then I get my g inverse function that is x plus 3 over 2. Now in this composition function, I'm taking f of g, but I'm solving it at the x value of 5, which means I have 2 options here. I can either take the 5 and plug it in for x in my g inverse function, and then take that answer and plug it into my f function. Or I could take my g inverse function with the x in it, plug that into my f function, simplify it, and then plug the 5 in. I, of course, am going to show you the shorter way of the 2, and then you're welcome to work through the other way. So the shorter way of the 2 is to take 5 and plug it into my g inverse function. So I'm going to go to this g inverse function that is x plus 3 divided by 2. I'm going to plug 5 into it. And when I do, I get 5 plus 3 is 8. And then 8 divided by 2 is 4. I then take this 4 and I plug it in for x in my f function. So then I get f of 4 gives me 4 squared, which is 16. It, of course, would work if I decided to take my entire g inverse and plug it into f, square it, and then plug the 5 in. It will work the exact same, as long as all of your math is right. So 430, I don't think I need to plug that one in since we've done a lot of these. You are just plugging them into their respective equations and then solving to see which one gave the biggest return. So 30 is not one that I'm going to focus on right now. For 31, I'm going to do 1 substitution, and then I'm going to do 1 elimination, and then that should be sufficient. And then on 32, I'm just going to do 1 of these. Okay. So on 31, I'm going to go ahead and do A because that's a substitution problem. Actually, I'll go ahead and do B. On A, you just set those 2 equal to each other, and then do cross multiplication and solve that way. So for B, I have x squared plus y squared equals 1, and I have y plus 2x equals negative 3. So on this one, I want to do substitution, which means I need to solve one of these equations for one of my variables. Clearly, I'm not going to solve the first one for anything because I'm going to have a really ugly square root in it. So I'm going to go ahead and solve the bottom equation for y. When I do, I get y equals negative 2x minus 3. I'm now going to take this negative 2x minus 3 and substitute it in for the y in that first quadratic type equation. So when I do, I get x squared plus negative 2x minus 3 squared equals 1. I'm going to go ahead and recognize that negative 2x minus 3 times negative 2x minus 3 will go ahead and FOIL out. And when it does, I get positive 4x squared minus 12x plus 9. So you're just going to FOIL this out. And then equals 1. I combine like terms to get 5x squared minus 12x plus 8 equals 0. I'm going to go ahead and do the quadratic formula because I don't anticipate this one factoring very nicely. So when I do the quadratic formula, I get 12 plus or minus the square root of negative 12 squared minus 4 times 5 times 8. And then all over 2 times 5, which is 10. I simplify this out a little bit, and I get 12 plus or minus the square root of 144 minus 160 is negative 16 over 10. This is where I need to stop. So because I'm talking about a coordinate plane and looking for intersection points, I know all of my answers have to be real numbers. I got a negative 16 under my square root, which indicates that my solution is not going to be real, but in fact is going to be complex or imaginary, which means that there are no real solutions to this function. So I could stop right here. Okay, because I'm only looking for real number answers, not imaginary number answers. So the next one we're going to go ahead and do is D. This one is going to be elimination. So I have 4x minus 5y equals 2. And I have 8x minus 10y equals negative 5. My goal here is to cancel out one of my variables and then solve straight down, solve for one of my variables, and then plug that back in to find the other one. So I need to decide which one I'd like to cancel. I actually kind of want to cancel the y's since they already kind of look like they're set up for it. The only thing is that I need them to have the same number with the opposite sign. So because this one's already a negative 10, I would like to make this one a positive 10. So I need to multiply this top equation by negative 2. When I do that, I get negative 8x plus 10y equals negative 4. I add straight down. My x is 0 out, and my y is 0 out, leaving me with 0 equals negative 9. Is 0 ever equal to negative 9? No, which means that this is actually a no solution problem. We're not guaranteed a solution, and if we are, we're not always limited to one. It could be an infinite number of solutions if I got 0 equals 0 here. Or if I had gotten like x equals 1 and I take it and plug it back in and solve for y, then I have one solution. So we're not limited to actually having a solution or having just one. I'm actually not going to go over. That is solving systems of inequalities. So we graph it like a normal number. We use a dotted line for single inequalities. We use a solid line for double inequalities. And then we plug in points to indicate the direction of shading. So if I plug in, say, 0, 0, and the inequality answer I get is true, I'm going to shade that line towards 0, 0. My solution then is the overlapping shaded section that worked for all of my parts. Okay? So those are lovely examples that are listed in the notes already. And other than that, if you have any other questions, please let me know. I'm more than happy to work with you individually if you have questions.